Hello, everyone. It's Miss Madison. We're continuing our study this week on Earth and space, and our focus is on the stars. Our standard is 5.ESS 1.1. Explain that differences in apparent brightness of the sun compared to other stars are due to their relative distance from the Earth. That also becomes our learning target, and in this that we will know what is difference, relative distance, apparent brightness. And we will show our understanding of this through explanation. Well, we will go into detail given this information. We're going to, this is how we're going to show what we know with a graphic organizer, have some test dependent questions because we have a rating, and also in our exit ticket. The vocabulary for this lesson is as follows. Star, an object in space that produces its own energy, including heat and light. Light year, the distance lights travel in a year. Constellation, any other patterns that are formed by a group of stars in the night sky. Nebula, a huge cloud of gas and dust in space that is the first stage of star formation. White dwarf, a star that can no longer turn helium into carbon. It cools and shrinks, becoming very small and dense. Supernova, a star that has produced more energy than gravity can hold together and has exploded. A black hole, an object whose gravity is so strong that light cannot escape. Our anchor chart shows the life cycle for a small and medium star, and this is what's at top, and also at the bottom for a massive star. We see at the end of a massive star life, it can either be a neutron star or a black hole. We'll go more into that in our study. Our first question that we are going to answer in our reading is, what are stars and why are some brighter than others? All right, and we'll begin with our reading. Keep our question in mind that we're to answer.
Stars. A star is a sphere of hot gases that gives off light and heat. The only star you can observe during the daytime is the sun. The sun is the closest star to Earth. Other stars are much farther away. Throughout the universe, stars are found in large groups called galaxies. Our sun is near the edge of a galaxy with billions of other stars. You may know this galaxy as the Milky Way. Our galaxy's nearest neighbor is the Andromeda Galaxy. Star colors and temperature. Stars are different colors. These colors occur because of the surface temperature of each star. Think about the flames of a bonfire. Different parts of the fire are different temperatures. Cooler areas are red. The hottest areas are orange-yellow. This same relationship between color and temperature applies to stars. The sun's temperature makes it look yellow. Cooler stars are red or orange. Warmer stars are white or blue. Like the Milky Way, the Andromeda Galaxy is shaped like a spiral. It is wider than our own Milky Way galaxy.
All right, so our question was, what are stars and how does distance play a part in how bright they shine? First, here on this page, we see a star is a sphere of hot gases that give off heat and light. And we know heat and light are both forms of energy. Our wonderful sun gives us heat and light each and every day. So those are two things that make up a star that give off heat and light. So let's see about that with the relative distance of a star to Earth and how bright it will shine. We're at star distance.
Star distances. The sun is about 150 million kilometers, 93 million miles, from Earth. It takes about 8 minutes for its light to reach Earth. Most stars are much farther away. The sun appears to be the brightest star because it is the closest star to Earth. Other stars may be brighter, but are much farther away. After the sun, The next closest star to Earth is Proxima Centauri. This star is about 40 trillion kilometers, 24.8 trillion miles away. Because stars are so far from Earth, writing their distance in kilometers or miles becomes awkward. To simplify the writing of such large distances, astronomers use a unit called a light year. A light year is the distance light travels in 1 year, which is nearly 10 trillion kilometers, 6 trillion miles. Proxima Centauri is 4.2 light years from Earth. When you observe a distant star, you are seeing what it looked like in the past. A star you observe today may have stopped glowing millions of years ago. However, its light is still making its way through space. The light we see from the Proxima Centauri system left there about 4.2 years ago. Skill Builder, read a diagram. In this diagram, Earth is right next to the Sun at 0. Count the light years from Earth's Sun to Alpha Centauri.
All right. So here we saw in the first paragraph that the Sun appears to be the brightest star because it is the closest to Earth. And other stars may be brighter, but are much farther away. So that lets us know that the closest the star is to us, the brighter that it will appear. So we can see that the relative distance of a star from Earth can greatly impact how brightly it shines, or how it appears to shine toward us. All right, so we're going to go back to our PowerPoint. All right, and so now we're getting ready to go to the second half of our reading. But before we do that, I want you to watch this cool video as it will relate to what we're getting ready to read about. Okay, what something cool to learn about black holes. Well, now that we understand how a star is formed and the type of energy that it gives off, and that it has two different life cycles determining the size of that star, let's learn and find out how it actually becomes a black hole. But before we get into that reading, let's focus on some test-dependent questions that I would like for you to answer as we're reading. What type of energy does a star produce? Why does a star glow? And last, approximately how long is a star cycle? All right, so let's go back to our text. Thank you for just working with me as I navigate through this. Here we are at star cycle.
Star cycles. Stars form when matter comes together and starts to give off energy. Stars go through stages or cycles between their beginning and ending. Different kinds of stars have different cycles. The cycle of a star depends on how much hydrogen the star contains. A star's cycle ends when it stops giving off energy. A star forms out of a nebula. A nebula is a huge cloud of gases and dust. Gravity pulls the mass of the nebula, most of which consists of hydrogen gas, closer together. As hydrogen atoms move closer, they collide with one another. These collisions produce heat, and the temperature in the cloud rises. When the temperature reaches at least 10 million degrees Celsius, 18 million degrees Fahrenheit, hydrogen atoms begin combining to form a new gas, helium. This process gives off tremendous amounts of heat and light. The nebula becomes a protostar, or beginning star. The protostar continues to gain mass because of its gravitational pull. Its heat makes it glow.
All right, so remember those test-dependent questions that I want you to answer. What makes a star glow? All right, and also what type of energy does a star give off? We also want to focus down here on the life cycle of a star, 1 through 5. Remember, this is for a small or medium-sized star.
1. Nebula. 2. Protostar.
Protostar. All right.
3. Star. 4. Red giant. 5. White dwarf.
All right.
The Sun, and other stars like it, started with a medium amount of hydrogen. That hydrogen is the fuel that produces energy in the Sun. For a few billion years, hydrogen atoms continue combining to form helium, and the star increases in temperature. Eventually, the heat forces the hydrogen on the edge of the star to expand into space. As the expanding hydrogen moves farther from the center of the star, it cools and turns red. At this stage in its cycle, the star has become a red giant. A red giant is many times larger than the original star. In the star's core, the temperature has risen to about 100 million degrees Celsius, 180 million degrees Fahrenheit. Helium atoms now combine to form atoms of carbon. When all the helium is gone, the star can no longer combine helium to form carbon. Now the star begins to cool and shrink, becoming a white dwarf.
Okay.
A white dwarf is a small and very dense star that shines with a cooler white light. The white dwarf stage is the end of a medium-sized star's cycle. About 10 billion years pass during this cycle. Because the Sun is approximately 5 billion years old, it is about halfway through the cycle. Skill diagram. Read a diagram. Follow the numbers to better understand the stages of a medium-sized star. The Sun is in stage 3 of this cycle.
All right, so let's look at this again. We have stage number 1, that all stars begin with nebula, 2, protostar, 3, star, 4, red giant, 5, white dwarf. And as we found out that our Sun is in stage 3, and it's approximately 5 billion years old, and it has many more years to go. All right, but we didn't hear anything about a black hole. Well, a black hole comes from a massive star. So as all life cycles of a star begin here at the beginning stages, let's see what makes it differ to where at the end it would actually be a black hole rather than a white dwarf. So let's continue on to our next page of reading. And we're only going to read the first section, star cycle of larger stars.
Star cycles of larger stars. Stars that start off with greater amounts of hydrogen end their cycle differently. After they become red giants, the temperature of the core of these stars increases to about 600 million degrees Celsius, 1,080 million degrees Fahrenheit. At this temperature, their atoms combine to form atoms of iron. Eventually, the iron core produces more energy than gravity can hold together, and the star explodes. The exploding star is called a supernova. Supernovas shine brightly for days or weeks and then fade away. A supernova will form a new nebula. If a star is very massive, it may end its cycle as a black hole. A black hole is an object that is so dense and has such powerful gravity that nothing can escape from it, not even light.
All right.
Star classification.
Oh, okay, all right. Now we see how we get that black hole. Now, once again, I do want you to continue to focus on those test-dependent questions. As for what type of energy does a star produce, why does a star glow, and approximately how long is a star cycle? I want you to keep those in mind because I want you to send those answers to me through Classroom Dojo or through my email, madisonrg@scsk12.org. Looking for those answers from you. All right, so here is our graphic organizer, and we're pretty much going to fill in the blank of the life cycle of a star. All right, they gave us some things to guide us along the process. We have black hole, protostar, supernova, neutron star, white dwarf, black dwarf, planetary nebula. All right, as we know that both a small, medium, and a massive star all begin here at the beginning as a nebula. Then they go on to the next phase, and when they get here pretty much at the third stage, it will be a red giant for a small or medium-sized star, or it will be a supergiant if it's a massive star. So at that point, that's when the stages begin to differ. once again, go back and look at the anchor chart that we have that will walk you through that, as well as go back and looking through the text. That's for your understanding of the different life cycles of a star. Now, we've gotten here to our exit ticket. And right now, as we're at the end, you've answered your test-dependent questions, you've done your graphic organizer, and I know you're so eager to send it to me once again through Classroom Dojo. Take a picture of it, send it to me, or through my email, madisonrg@ssk12.org. We have 3 exit tickets here. I only want you to do 1, but if you would like to do 2 or 3, go ahead, do it. All right, so our exit ticket is the figure below shows what the sun, which is a star, medium size, look like in the sky on each planet in the solar system. And our planets are in order: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and we don't see Pluto because it's not a dwarf planet. All right, so question number 1, how does the brightness of the sun change as the planet's distance from the sun increases? 2, there are many stars that can be seen from Earth. Explain why the sun is the brightest star in the Earth's sky. And 3, during most of its orbit, Pluto is farther from the sun than any other planet. Parker claims that most of the time the sun will look less bright from Pluto than from Neptune. Do you agree with Parker? All right, that is our exit ticket. You can go back and review the information within the readings and the PowerPoint to answer the question. I'm looking forward to getting the answer to your test dependent question, your graphic organizer, as well as your exit ticket. Do this with someone at home, your parents. Let's have a wonderful time learning about science together. As you begin to go outside and able to look at the night sky, when you look up at that star, I want you to point to the star and say, hey, I know why you shine that bright here on Earth. See you next time. Miss Madison, stay safe, stay healthy. I love you. Bye.